In this video, I'm going to talk about designing for inheritance. I'm going to start by saying, do we even need to design for inheritance? You might not want to. We're going to talk also quite a bit about the protected accessibility modifier. What we're going to do here is we're going to look at a bunch of different patterns that are in common use for designing virtual methods that can be inherited. We are by no means going to look at all of them. There's a huge number of different possible patterns here. We're just going to look at a couple of characteristic ones. So let's start with my ongoing skepticism for the value of inheritance. I think it's often overused. The first question that I always ask myself when I'm considering designing a class for inheritance is, how many derived classes do I expect that I am ever going to have of this thing? If the answer is 0, then I certainly don't design the thing for inheritance. If the answer is 1, then I might stop and think, well, shouldn't I just be designing one class that does what I need it to do anyway, right? If the answer is 2 or more, then yes, I'm definitely thinking, yeah, I'm probably going to want inheritance here. And the other thing that I think about is, as I said in the previous episode, every time you call a virtual method where the receiver is of the base type, you are essentially saying, I'm hoping that the derived type is going to do the right thing, but I don't necessarily know what it's going to do. I haven't necessarily tested what it does. I can't necessarily predict what's going to happen next. That worries me, and I would like to try to remove that uncertainty as much as I can. So the first thing I ask myself then is, do I even want to have this class unsealed, right, so that I can allow somebody to derive from it? Or should I seal it and say, you know what, nobody can derive from this thing? So I think there are 3 possibilities, right? I could leave the class unsealed, and I could just simply not even worry about it. Just say, you know what, I'm not going to design this thing for inheritance. If somebody wants to inherit from from this thing to make it their base type so that they can make a derived type, that's up to them, right? They could do that, and if it works, great. And if it doesn't, then oh well, this was not something that I designed for. So maybe it'll work by accident, and that would be good. Or I could say, well, I'm going to leave this class unsealed, and I'm going to carefully design it so that somebody can successfully derive from this. Now that involves thinking about what other people are going to do with this class. Now those other people might be you and other members of your team, or it might be somebody else in some completely other company, depending on how public your class is. But no matter what, it requires thinking about what people are going to need in the future, and then carefully designing and implementing and testing a class that is going to meet the needs in those scenarios. Or you could just seal the class. And in this case, there's no danger of getting the design wrong, because there is no inheritance. The class is sealed. But there's no chance of getting it accidentally right either. Now, the nice thing about sealing a class is, suppose you seal a class and then somebody comes along and says, you know what, I would really like to derive from this class, and I'm willing to take on the work of making sure that I do it correctly, and I already think that this class is going to meet my needs as a base class. You can always unseal a class. It's not a breaking change to unseal a class. So I tend to err on the side of, I'm going to mark this type as sealed if I don't intend it to ever be overridden from. There are many people out there in the world on the internet who will tell you that they much prefer the first option, to say, you know what, I always leave things unsealed. I don't necessarily design for inheritance, but if somebody wants to use my type, then that's on them. Let's assume that you do want to leave your class unsealed, that you're going to design your class so that it can be inherited from, so that somebody can create a derived class that works. What are we going to do? Well, you know that public members are already accessible to all of the code that can see your class. You know that private members are implementation details. They are not accessible to derived classes. That is actually, in a way, a tiny lie. There are a couple of ways in which private members can become accessible to derived classes. We are not going to talk about them in this course. They are quite unusual. So how do you make a member designed for the convenience of the author of a derived class? You can't make it public, because that's something that anybody can use. You can't make it private, because the person who's designing the derived class won't be able to see it. Well, let's take a look at some code, and we'll see how to do this. All right, so the question that I have at hand is, first, is there a way to do this without adding any new accessibility modifiers? And so, for example, could I design my person base class more cleverly so that the author of the president class that's deriving from it doesn't have to do quite so much work? So let me give you an example here. Right? Once again, we have our constructor, perfectly normal. I'm going to have our virtual property from last time that returns an empty string in the case of a person and returns the string president in the case of the derived code. But I'm going to change the implementation of our toString override. You remember in the previous code we had object.toString, and then we overrode it with person.toString, and then we overrode that with president.toString. Well, I'm going to say, you know what? I'm going to think about what the needs of my future derived classes are going to be. And I'm going to say, you know what? If the title is null or it's just white space, then return the name. Otherwise, I'm going to say, give me the title and then a space and then the name. And that will be our default toString behavior for instances of person. So now, when somebody creates a president-derived class, they don't need to override toString. An implementation of toString already works for them, provided that they override title, which they were going to do anyway. Or you can think of, well, suppose there is yet another derived class of this thing, right? That is senior manager, right? And that person would like to have a title, or doctor, or whatever. There may be multiple derived classes from person that wish to override title, and now all of those classes don't need to override toString. They all get it for free. So this is kind of a nice way to do it. Right? If we look at our president type. I've sealed it because I don't expect this ever to be extended from. And now we've gotten rid of our implementation of toString because we don't need it anymore. All right, so that's a pretty straightforward way to think about what developers are going to need in the future if they're going to derive from your type, and to just be a little bit mindful and say, well, let me give them a service. And of course, if they don't like that service, they can always override toString with their own implementation if they want. But I'm going to hope that most of the time they don't have to. All right, so let's think now about this problem of, well, we've got these methods that are public, we've got these fields that are private, but I want to provide a service just for code that is in a derived type. There's a accessibility modifier called protected that is just for that. A protected member can only be accessed in the current class or by a derived class. So it's not public. A public member is one that can be accessed by any code that can see your type. And it's not private. A private member can only be accessed by code that is within your type. A protected member is less than public, but it is more than private. So let's think about our abstract class here, change request. An abstract class can only be instantiated by the creation of a derived class. We know that. We also know that the derived class will call the constructor of its base class. And therefore, the constructor in an abstract class can actually be marked as protected. And this is pretty common. In most code, you mark the constructor of an abstract class as protected, because it's not like code out in the public, out elsewhere, is ever going to be calling that constructor. It can't, because the class is abstract. So here I've added the protected modifier, removed the public modifier to change request. So that's a common use of protected. The other more common use of protected is to just simply make a helper method in the base class that does some computation or provides some service that can be used from derived classes. It's an implementation detail of the base class, but you think, oh, you know what? This thing provides a service that will be useful to the code that is deriving from me, but I don't intend to make this part of the public surface area. And that's perfectly fine, and I'm not going to labor the point of how that works. I'm not going to show an example of that. It's very, very straightforward. I want to look at a slightly more subtle use of protected methods, and that's protected abstract methods. So before we had a virtual method that we called submit request, and we didn't bother to implement it, right? I just wanted to show that you could have an abstract method in an abstract base class, and that would then force your derived classes to provide implementations if they were concrete classes. Now, suppose we wanted to be a little bit fancier here, and we wanted to say, you know what? The base class wishes to enforce a workflow. And that workflow is that when a request is submitted, two things have to happen. First, it has to be validated. If it is validated, great. If it's not validated, then that will throw an exception. And then once it's validated, it must be persisted to a database. So here's a way that we could enforce that workflow. Right? I've taken the submit request method. It's no longer abstract. It has a body. It's no longer even virtual. I've just made it a perfectly normal public instance method, so this thing can no longer be overridden. And I've said, well, what do? Well, we validate the request, and then we persist it to a database. Now, I've made these two methods protected and abstract. They are abstract because we require that the derived types implement them if they're concrete. But they're protected because we don't want code that is outside of this class hierarchy to be able to call persist to database without first calling validate request. So these methods have to be inaccessible to the outside world, but they can't be private because they have to be accessible to the derived types, because the derived types have to override them. And you can't override something that you can't see. As we discussed previously, you can't even make a private abstract or virtual method. So what I've done here is I've said, once again, we've got this submit request method. It's not virtual, but it calls two virtual methods. In fact, it calls two abstract methods. And now defect fix request is required to implement validate request, which I haven't done here, and required to implement persist to database, which again I haven't done here. I'm not actually writing an implementation of a defect tracking system here. And submit request goes away. It's no longer virtual. We can no longer override it. I've simply deleted it. Right? So this is another way that this class hierarchy could have been designed. And now the design of the base class enforces certain restrictions in the design of the derived class. It strongly encourages the people who are writing the derived classes to do the right thing, to say, you know what, I'm going to need to validate this request, and then I'm going to need to persist it to the database. Both of those things have to happen. I need methods that can do that. Now, here is an interesting question. Suppose I have a method. I'm just going to make a static method here. It doesn't really matter. It takes a change request as its argument. Can I call persist to database on that thing? Remember that persist to database is a protected virtual method. Well, you think, well, we're in a derived class. It is a protected method. I should be able to call it. But in fact, if we look at this thing, it says, cannot access protected member via a qualifier of type change request. The qualifier must be of type defect fix request. Right? So what this is saying is that the receiver here is of the wrong type. Well, how is this wrong? Well, this could be any change request. Right? In fact, this could be, we're in the defect fix request code. This could be a feature request, in which case code that is written inside the defect fix request class could be doing a virtual method call to a protected method that was actually implemented by feature request, our other derived type. And that seems wrong. The idea of a protected method is not, it's a free-for-all. Any code in a derived type can call this method. The idea is any code in a derived type can call this method in itself, not in any of its sibling types. So C# is saying we cannot prove that this change request is actually of the type defect fix request. If we change this to defect fix request, right, then the error would go away. Now it would say the receiver of the call I know is a defect fix request. Therefore, I have no chance that I am calling a virtual override that was provided by some sibling class over here. All right, so let's just follow this through in the debugger. I'm going to step in here. I'm going to create two persons, me and my good buddy, President Obama. And there's going to be a new defect fix request submitted by President Obama saying that healthcare.gov is running too slowly and that he would like me to fix it. And so now when we submit this request, let's see what happens. So we step into the non-virtual instance method, submit request. Right? And it says, what do I need to do? I need to validate this request. Well, that's an abstract method, so it's virtual. So we will do the call on the method that is implemented by the derived type. And then we step into validate request inside the defect fix request. Right? We would do the validation, persist it to the database. So now we have enforced that anytime submit request is called, we know that validate request will be called before the thing is persisted to the database. The person who wrote the base type knows that. They wish to enforce this upon the people who are writing the more derived classes. And notice that we cannot call the protected method from outside. Right? So here we are in a class program. It has no relationship with the change request hierarchy. And if we try to call validate request, then this will say validate request is inaccessible due to its protection level. Its protection level is protected, and it's not accessible out here. So summing up, inheritance is a feature. It's like any other feature in a class that you're designing. You want to decide if you want it. You want to prioritize it against other features, and you want to implement it carefully, thinking about how are the people who are going to derive from this type, what operations are they going to do, what scenarios are important to them, what conditions do I need to enforce. Use the protected accessibility modifier to create members that are useful only to derived classes, so that they're not private implementation details, but nor are they part of the public surface of your class. And protected members come with some additional restrictions on how they can be used that can sometimes be confusing. So if you get a message saying, hey, you're not allowed to call that protected method, now you know why.